Hello students, today we are going to study Stokes theorem. So before going into the Stokes theorem, first of all we will see the importance of Stokes theorems, why Stokes theorems is essential. So this theorem can be used to convert surface integral into line integral and vice versa. It means one can convert from surface integral to line integral or line integral to surface integral mathematically by using this theorem. So now we will see the statement for this Stokes theorem. So before quoting the statement, so we will first see what is the mathematical expression of Stokes theorem. So mathematically Stokes theorems can be written as, so this surface integral oval curve of vector field A vector is a vector field, is equal to the line integral over the vector field. Or this can be written as this. We know that curl of vector A can be written as del operator cross a vector field A. So del cross A dot ds is equal to the line integral. So what is the statement then? So it states that the surface integral of curl of vector field A taken over an open surface, the surface is open, okay, is equal to the line integral of vector field A around any closed curve C of that surface. So this is the better statement for Stokes theorem. It states that the surface integral of curl of vector field A taken over an open surface S is equal to the line integral of vector field A around any curve C of that surface. So this is the statement and mathematical expression for Stokes theorem. Now we will see the proof of Stokes theorem. So for proof, first we have to consider this is a closed curve C. So this is the smooth closed curve C, and the direction of this closed curve is this anti-clockwise direction. And suppose this closed curve C encloses an open surface S of vector field A. Okay, now we have to consider this open surface S is made up of large number of surface elements. Okay, so say this is a small surface element, that is del s1, and the direction of this surface element, suppose anti-clockwise, okay, which encloses a boundary length delta l1. Suppose this is second surface, neighboring surface element to the delta s1, that is delta s2, okay, having a boundary length delta l1. Suppose this is third surface element having surface area delta s3, having boundary length delta l3. So whatever we have quoted in the diagram we can show in the text also. So consider a smooth closed curve C encloses an open surface S in a vector field A. Okay, and we have considered the surface S be divided into large number of small surface elements, say delta s1, delta s2 up to delta si, and having boundary lengths, okay, enclosed by this curve or boundary length del l1 plus del l1, del l2 up to del li. Okay, now by the definition of curl of vector field, we know that curl of vector field A is nothing but the line integral of vector field per unit area. So we have seen this formula when we studied the curl of vector field A. So curl of vector field A is nothing but line integral of vector field A per unit area. So curl of vector field A, so we will find out the curl of vector field A for small surface element, that is delta s1. So for the surface element delta s1, curl of vector field A, that is curl of vector field A into delta s1, is nothing but line integral along delta l1 A dot vector A field A dot dl vector. Okay, suppose this is equation number 1. So for second surface element, that is delta s1, so this expression for delta s2, sorry, second surface element delta s2, so this expression changed for delta S2 is this, curl of vector field A into delta S2 is equal to line integral along closed boundary or closed curve delta L2 vector A dot delta dl vector. So suppose this is equation number 2. Now we will now so on we will find out the find out for the surface element delta Si. So similarly up to delta Si we have found, we will find out this curl of vector A. Okay, so for the surface element delta Si, the curl of vector A into delta Si is equal to the line integral of vector field along the boundary closed boundary delta Li. So suppose this is equation number 1. Now we will add both sides of equation number 1, 2 and 3. So adding both sides of equation number 1, 2 and 3, we will get this long expression, curl of vector A into delta S1 plus curl of vector A into delta S2 plus up to curl of vector A into delta Si is equal to line integral along delta L1 plus line integral along line integral of vector field along delta L2 plus up to line integral along delta Li of vector field. So see the left hand side, curl A is common term, so we can take outside. So this curl A in the bracket delta S1 plus delta S2 plus up to delta Si, this sum will remain in the bracket. So we can see that in left hand side there is a sum of surface elements, okay, area of surface area of surface elements, and here we can see the sum of line integrals. So this sum can be written in terms of the summation over I, if suppose I is equal to 1 to n. Okay, so this can be written in the summation form. So next step, summation over I equal to 1 to n. So now curl A into delta Si, I equal to 1 to n, is equal to summation over I equal to 1 to n line integral line integral along delta Li vector A dot dl vector. Okay, now we will impose one condition, that suppose number of surface elements are infinite or there are many surface elements. So when number of surface elements are infinite, so their area will be very small. It means the area of small surface elements tends to 0. Therefore summation of left hand side of equation number 4 will be converted into the surface integral, because surface area, that is del Si, tends to 0. So this will this will change into the surface integral over S. So left hand side of the equation number 4 can be changed to, therefore equation number 4 becomes surface integral over entire open surface S curl of vector A dot ds vector, okay, equal to the summation over I equal to 1 to n line integral along delta Li A vector dot dl vector. So suppose this is equation number 5. Okay, now as the line integral along the common boundary of two small surface elements will cancel each other, okay, being in opposite direction. So what is the meaning of this sentence? So we will see, again we will see the diagram. Okay, this is the diagram. Now suppose these are two neighboring surface element. So this is the common surface, okay, common boundary, this is common boundary between two surface element. So we will see that this, suppose the direction of this surface element delta S1 is anticlockwise direction of boundary, suppose this is in this direction, and the direction of this is suppose in this direction. So we can see that the common boundary between two surface elements having opposite direction, so they will cancel out each other. Similarly the common boundary between these two surface element will cancel out each other. So all the common boundaries inside all the common boundaries of neighboring surface element will cancel each other. So we will only this curve or only the whole boundary, that curve C, will remain. Okay, so now see this, So as the line integral along common boundary of two small surface elements will cancel each other being in opposite direction, therefore right hand side of equation number 5 can be represented by sum of line integral along the whole closed curve C. So left and right hand side of this equation number 5 will be equal to the line integral over around closed curve C of that surface, that is for line integral of vector field, okay, along the closed curve C. So suppose this is equation number 6. Now equation number 5 is this, and this is equal to line integral along closed curve C. So from equation number 5 and equation number 6 we can say that, now we can write that surface integral over open surfaces, surface integral of curl of vector field A over a open surface S is equal to line integral of vector field A around closed curve C of that surface. So this is the final expression for Stokes theorem, and this curl of vector A can be written as del cross A. So this is the final expression of Stokes theorem. So today we have seen importance of Stokes theorem, statement and complete full proof of Stokes theorem. Okay, thank you very much.